Hi everyone, this is Sam Gabriel, and in today's video we are on actually our second video in the series on end-to-end infrastructure and application deployment, the project that really is trying to look at an entire CI/CD pipeline of how to secure that pipeline using Vault, and also how to tie the best of breed tools to be able to provision your infrastructure and then run your application on that infrastructure. In our previous video, we talked about Vault and using the Azure Secrets Engine within Vault to be able to grab Vault credentials dynamically, and from there get those credentials and place them, let's say, inside of Terraform to go out and provision infrastructure inside of Azure. So today, let's take a look and see the next step in our project, and this is a very important step where we're actually going to build our Jenkins machine that will take care of our CI/CD pipeline. So again, this is going to be done once really by an admin who has access to Vault and also has access to be able to run Packer, Terraform and Ansible, all of that to configure the machine, the Jenkins machine inside of Azure. So let's get going and see what we have in store for today. All right, as I mentioned, we've completed step 1. So now let's jump into step 2, Jenkins setup. Agenda for today, introduction, we just went through that. The overall goal, kind of do a recap from what we did in the last video. And if you haven't watched the last video, I highly encourage you to do so because we're building on that. And I'll put a description in the, I'll put a link in the description of this video below. Also, if you haven't subscribed already, please do so and click the bell button so you can get notifications whenever we release a new video. Okay, Packer images in Azure. That's what we're going to do next. We're going to build an image in Azure using Packer. And then we're going to use Terraform to build a VM based on that Azure Packer image. We'll, of course, do all that in a demo as well. And some concluding remarks at the very end. So recap of our overall goal. As you recall, the first step was a Vault admin to get access to Vault and be able to configure the Azure Secrets Engine to get the ability to grab dynamically secrets from Azure, or credentials for Azure. The next step, which is the topic of today's video, is this blue or light blue container here, where you can see a DevOps persona. He or she needs to create, first of all, an image, an Azure image using Packer. Then Terraform will create a VM, and that VM will really only have Docker running in it. But then Ansible will come in and create, actually pull the image, the Docker image, and run that Docker image to get Jenkins up and ready. And we'll see how that all works. And in the next couple of videos, we'll talk about secure introduction, how to put the Vault token inside of Jenkins, so then Jenkins can grab secrets for the application, or even the Azure credentials dynamically from Vault. How do you do that securely? That's the topic of the next video, as I mentioned. And then finally, the last video is how to tie everything together to be able to build the infrastructure and finally deploy that infrastructure, deploy the application on that infrastructure we just built. All right. Recap of topics to learn. So last video we talked about Vault Azure Secrets Engine. This video will learn about Packer and how to create a Packer image inside of Azure. We'll also learn about how to use Terraform to build a VM based on that Packer image. We'll also learn a little bit about Ansible to configure the Azure VM. Should have highlighted that in light green here. So we'll do that in this video. Then topics for next video is Vault Secure Introduction using Vault App Role. Then tying everything together in a secure CI/CD pipeline with GitHub, Jenkins, Terraform, Ansible, and Vault. Also looking at the application itself, the Python Flask application that talks to a backend MongoDB for the web blog that we saw before. So using the Dynamics database secrets engine with MongoDB, the Vault Transit secrets engine, and finally tying the Python Flask app with the MongoDB database using console service mesh to talk to each other. Okay, so the topic of today's video is setting up Jenkins. So as you can see here, we have a DevOps person and a number of tools that he or she would use. All right, so we start off with Packer. Building an Azure image containing Docker using Packer. And that will get deployed in Azure inside of that same resource group that we saw in a previous video. Then we need to get the Azure credentials dynamically from Vault. So Vault reaches out to Azure, gets those dynamic Azure credentials, gives them back to the DevOps admin, and then inject those credentials into Terraform. From here, the Jenkins machine gets provisioned via Terraform. Terraform comes back, provides the fully qualified domain name and IP address of that Azure VM that Terraform just provisioned. So then the DevOps person can run a playbook with the IP inside that playbook, or the fully qualified domain name inside of that playbook's inventory file, so that Ansible can go into that VM, SSH basically into the VM, and configure that VM to run a Jenkins container. And then at the very end, that will give us a Jenkins machine that's running inside of Azure that contains, we'll see in the Docker file itself that we actually build an image that contains not only Jenkins, but also the Terraform Vault binaries and also Ansible, so that in the next few videos, we'll see how Ansible now becomes, Jenkins now becomes the brains of our operation. It will carry on with the CI/CD pipeline builds. And that pretty much sums it up for what we'll do today. So let's go ahead and take a look at a demo. All right, so let's take a look at our Visual Studio Code and look at our folder structure. As you can see here, we have a bunch of folders. We've got an Ansible folder. Inside of the Ansible folder, we actually have a Jenkins VM folder as well. We're going to add another folder when we start to use Ansible for configuring and building our application. But for now, we have this folder that's going to bring up Jenkins for us, right? The application folder, this is where the weblog source code lives. So we'll talk about that in later videos. Don't worry about it now. Jenkins, this is the folder where we have the Docker file. And Packer is what we're going to work on right now. Basically, it has the configuration necessary to build the Packer image inside of Azure. And then finally, Terraform has a couple of folders. The first one is what we'll focus on in this video as well, talking about how to build the Jenkins VM. So we have some configuration files we'll take a look also at. And there's also another folder I haven't populated yet. This is for provisioning the infrastructure for the weblog app to run. Okay, so let's go ahead and start with Packer. So we need to build an Azure image that contains Docker. So that's the first step that we need to take, right? So to do that, let's open our Packer folder and let's take a look at what needs to be done here. So first thing is we need to add the Azure credentials inside of the variables.json file. Now this is hidden. I'm not going to push this into the GitHub repo, but I do have a sample example for you of what that will look like. So as you can see here, the variables file for Packer contains our client ID, our client secret, tenant ID, subscription ID, so all this information you need to be able to access Azure from Packer. The resource group, if you recall, that's what we configured in the previous video. So Samg Jenkins. A Packer image name. So this is what we're going to call it. The VM size, the location, and the image SKU that's going to be used. So we're going to run a Ubuntu 18.04 Packer image. Okay, now the next step is to take a look at our Ubuntu 18 JSON file. And if you've seen my previous video on Packer, I've created a couple on Packer for VMware. So one for Windows 2019 images, and also another one for Ubuntu in VMware. So it's quite similar, the same idea here that we built for Azure. It's actually a bit simpler. The first thing is you need a builder's block. In this case, the type is Azure ARM. And here is where we once again tie into the variables that we just defined. So client ID, this is how we define variables inside of Packer. So user, first you write user, and then these ticks you put in place, and then you put the actual name of the variable that we saw in here. So this one, this client ID is what matches or maps to this client ID right here. So again, do the same thing for the secret, the tenant ID, the subscription ID. The managed image resource group is that resource group we saw, the Packer image name. OS type is Linux, canonical, Ubuntu server, image SKU is what we define in the variables section. You can add some tags here as well if you wish. Location and size of the VM. Then the next block after the builders is the provisioners. Here is where you can define certain certain commands that you can run inside of the machine once it's built. So for example, here we're doing an apt-get update, an upgrade, and then we're installing Docker. A very simple way to install Docker. And then if you notice and if you look at the Packer documentation for building Azure Linux VMs, they have this here where you need to deprovision. You need a deprovisioner to get the machine, the Packer machine, ready to be deployed, right? So you just need to run these commands here, this command here, and also these commands as well. So I'm just following what was in the documentation. That basically gets our image ready to be deployed later by Terraform. It removes anything specific to this particular image, so it becomes a template that can be used over and over again to build VMs based on this template. Okay, so that's it really. What we need to do now is, let me follow my instructions here. You can run this command, packer build. The force tag is if you're rebuilding the image over and over again, you need to force it, because if Packer finds that the image already exists, it's not going to override it. So the force tag or flag overrides it. Okay, so let's go ahead and get into my terminal and let's see where this path is. Okay, so cd let's just clear this. CD deployments HashiCorp. Okay, I'm going to Packer. Okay, so this is what we need. Let's run this command. So as you can see, it's going to start looking at the resource group, contacting Azure. And if something goes wrong, you're going to see a big red script telling you exactly what the issue is. So this might take a little bit of time. So what I'll do is I'm going to pause the video. And once it's complete, we'll resume and we'll go through this log file to show you what actually occurred. Okay, we're back. So you can see it took 12 minutes and 13 seconds here. So let's go to the top of the log file here and see exactly what happened. A couple of notes that I want to bring to your attention. Packer actually creates a random resource group name. So it's a random resource group that gets created inside of Azure that builds the image, and then it deletes the resource group at the end. The reason why I'm pointing this out is because, well, in the previous video, remember we created credentials for Azure using Vault. However, I tried to use those credentials inside of Packer and it complained it didn't work. The reason for it is that those credentials, if you recall, were tied to a certain resource group called samg-jenkins. So that was defined in the Vault role. So now, because Packer is using a random resource group, so these credentials didn't work, right? So I'm just using the regular service account credentials, or service principal, I should say service principal credentials that I've actually used with Vault to talk to Azure, right? So, you know, the persona here needs to be an admin that has access to those credentials for Azure to run Packer. Okay, so really you're not going to run a lot of Packer images. You're not going to give it to your developers, for example. These are going to usually be your gold images or master images, if you will, that get created by admin level people, and then you can consume, the devs can consume those those images when they're running Terraform, for example. So here you can see that it created the resource group, and now it's connecting to SSH, so to run the provisioner after the build completed, and it's doing apt update, as you can see here, doing an upgrade to the packages as well. There's an error message here that I don't think is important, something to do with the terminal. And it continues to unpack and update and upgrade. And you can see Docker right here gets installed. And that is pretty much it. You can see deleting additional disks. What else is worth mentioning here? Then the cleanup happens. Resource group has been deleted, so it's an ephemeral resource group that we talked about. The deployment here gets removed as well. And yeah, it took 12 minutes and 13 seconds. And the resource group that we were talking about is, so this image got created inside of the samg-jenkins resource group. Here's the image name, here's the subscription, and the location where this was created. So we can go back to our Azure console and let's refresh this. Okay, so I'm inside the samg-jenkins resource group, and you can see the image that got created is right here. Okay, perfect. So we're all set. We have finished this piece. So Packer is done. Now the next step is to go ahead and build the VM based on Terraform. Okay, so let's go ahead and do that. Now I did make a change here. This is again tied through GitHub's version control system. So I'm going to go through this code, but let's go ahead and run Terraform so that we save some time. Okay, let's see here. Let's go ahead and say create Jenkins VM. Let's commit that. And once it commits, we'll push that over to GitHub, which once again will automatically generate a plan inside of Terraform Cloud. I'll just wait until this is complete, and then we'll go into Terraform Cloud to take a look. All right, so that's done. Let's go ahead and go to Terraform Cloud. So I have this workspace called End-to-End Infra App Deployment Jenkins Azure. And the variables that I'm using here, the subscription ID, tenant ID, client secret, VM size, admin user, and no environment variables. So what I expect to happen is this will fail because I used an old client ID and client secret that I used from Vault previously before recording this video, and that was a few days ago. So if you recall, the lease time or the time to live is 24 hours. So I'm sure this is expired by now. So we should get an error message, and sure enough, we got an error message: error building account, error getting authenticated, object ID. So basically, it's telling you, hey, I can't authenticate here. There's a problem. So what we need to do is go back to our terminal here. Let's clear this, and I have it here in my history. This is the command that you need to run: vault read Azure Creds Jenkins. Make sure you're logged into Vault, and make sure that you have the proper environment variable with the Vault address. So I got a new client ID and a client secret, so now I can copy these. Once again, this is going to be done by an admin. So the variables that I can change here are client ID. And the reason why I'm doing this manually, obviously, is because I don't have the pipeline yet. I don't have Jenkins up and running. I'm trying to build Jenkins, so this really has to be done manually, and it's not completely manually, as you can see. Let's put the client secret here. We're still running some automation. What I mean is that there is no pipeline, so basically I have to manually run Packer, then manually run Terraform, then manually run Ansible. Later on, we'll find out that you're going to automate this so everything runs seamlessly. Okay, so the client secret, worth noting that again, it's a sensitive field, so it's saved here as a write only. And again, it's 24 hours, so by the time this video is published, it'll be long gone, the secret, so I'm not too worried if you see it. Okay, so now that this is in place, I can go ahead and queue the plan from here, or I can commit and push, but let's just queue it from here and get it going. And once it passes the checks and the plan is good, we can apply it and then go back and explain what happened with the code and how this all works. Okay, so we passed the first stage here. It means we've connected successfully to Azure. From what I'm seeing here, 7 changes will happen, 7 to add. Just waiting for the cost estimation to take place. And we're estimating about $14 per month to run this. Now, the virtual machine that I'm trying to run, hourly cost is 2 cents, about $14.40 to run this. Okay, so let's go ahead and actually gives you it's an A series. That's standard A0, I believe, is the machine we're calling on. Let's go ahead and confirm this, apply, and let it run while we go through the code. Okay, what does this all look like? Let's take a look at the variables file first. Yeah, as you saw in Packer, it's very similar. Subscription ID, tenant ID, client secret, client ID. This is the declaration of the variables in the variables file. A prefix defaults to SAMG, location, central US, an address space, a subnet prefix, VM size, an admin user name. Yeah, you can see here the standard A0 is the VM size that we're using. Define your address space and your subnet, and then the I actually should change this. Specifies the username. Specifies the admin username. Let's save it. Okay. Output, what do we expect? We expect to see the fully qualified domain name for this machine. So we can use that in our inventory file for Ansible. Okay. Let's go to our main file and go through this. The required provider here, always pin the version. Azure RM, always pin the version so that in case down the line you give this code to someone else or you rerun it, there's no breaking changes. The provider here is calling on all the variables that we showed before. Locals, this is a neat way of creating tags. So you know, at HashiCorp, we'll always have to make sure we're tagging the resources to make sure we know who's doing what. So you can see here an example of the tags that get used. So locals and then common tags, and then you can refer to these common tags in different places within the code. So what are we doing? We're grabbing the resource group that we talked about earlier, SAMG Jenkins. We're also grabbing the image, the SAMG Docker image that we saw that Packer built. Then we're creating a virtual network, so a VNet, giving the same prefix that I called earlier. Location, address space, resource group, all that's been defined. Then we're creating a subnet, and then a security group, network security group. So what are we doing? We're opening port 8080, which is the default port that Jenkins is going to listen on. 443 we don't really need. I guess I had this from a previous example. And port 22 to be able to SSH into the machine. And then we're creating a NIC, so a network interface. Okay, and you can see the public IP here. That's what we're going to see later. It's actually the fully qualified domain name that we'll pick up in the output file. And let's see, this is a security group association. So this associates the network interface ID with the network security group ID. So it ties the NIC with the security group here. So it ties them together. Over here, we're looking at the public IP that we're generating. And it's a dynamic allocation method. Then finally, we're creating the virtual machine. We're giving it the name SAMG-Jenkins. The location, which resource group that we grabbed earlier, the size of the VM, the admin username. We're tagging it here with the tags we saw in the beginning of the file. The network interface ID, the actual admin SSH key, so the username we saw earlier, plus the public key file, which is a file I have here. I copied it into my repo so I can log into this later and have Ansible actually log into it or SSH into it. Source image ID, that's the image ID that we'll grab from the Packer image that got created. So the Packer image that got created, like I said before, is being pulled here with this data variable. So we're just grabbing the ID from here, tying it down here, or calling it down here as we're building the VM. Okay, so Terraform is building a VM based on that Packer image that we created earlier. Then we're building an OS disk, as you can see. Now, why did I comment out this? So this is where some best practices come into play. You know, so Terraform has the concept of provisioners. So you can see this provisioner. And what a provisioner does, you can see here, you can remote exec, you can SSH into, so using this connection type SSH, into the machine that got created, the VM that created, to do different things. You can run commands. So I was trying to run the Docker command to create the container and get the container to run, I ran into a bunch of problems with that. And that's because this is not good practice. It should always be a last resort if you ever need to run a provisioner. Really, you shouldn't need to run a provisioner. And that's where Ansible comes into play. Terraform is very strong at provisioning, but when it comes to config management, Ansible does a great job at doing that and keeps track of that. So when I tried this, I ran into all kinds of problems, and that's when I decided, you know what, let's follow the best practice. Let's hand this over to Ansible to do that. Okay, so let's go ahead and see how far we've gotten. Oh, apply has finished, and we have our Jenkins public DNS right here. So this is our fully qualified domain name for the machine that we just created. And if I go back here and refresh our resource group, we should be able to see everything that got created. So you can see the IP address, the public IP address, the virtual machine, SAMG Jenkins, the NIC, the disk, security group, the VNet, and so on. Okay, so that's perfect. We created our VM with Terraform, and now the next step is to run Docker through Ansible to bring up Jenkins. Okay, so let's go back to our folder here. We're done Terraform. Let's close this. Next on the list is Ansible. And let's go ahead, open the inventory file. In here I have Jenkins. The admin user is admin user. The interpreter is Python 3. And I actually have the host name, Ansible host. This should be the same. Yeah. This is what I grabbed from the output file from Terraform. So this is what Ansible is going to do. It's going to SSH into this machine. And from here, run the playbook. And this is the playbook that's going to run. So why don't we run this playbook and then take a look at this code. So here's my code that I need to run. So let's go back to our shell command. And you got to be inside of Ansible. So okay, perfect. So let's run this Ansible playbook -i inventory my playbook.yaml. Okay, so we ran into an issue here. Let's see what this is all about. Oh, I see. Okay, so we have to remove this file. Let's see. Remove with this. Okay, let's remove this. Actually, the output here is a bit messed up, so I'm gonna try to manually SSH admin user. Oops. Let's grab this again. SSH admin user at this, and this is how we remove it. Okay, now let's run the playbook again. Actually, while this playbook runs, let's go ahead and take a look at the code, save some time. So what are we doing in this playbook? So we have a few tasks here. Hosts all, so we're doing it against all the hosts in the inventory file, which is really one host, which is Jenkins. Become root user, yes. Now the tasks. First one, install Docker module for Python. So we're running a pip with this module Docker. And the second task is pull the Jenkins Docker image. So this is the image that I have here that I built earlier. Actually, we'll take a look at the image just a minute. So what is it going to do? It's going to get that image, it's going to pull it. Force source yes, in case I made changes to it. Make sure you always pull it down. Create Jenkins container. This is where we're going to run the container. So you can see here, give it a name. We're going to name the container Jenkins based on this image. State is started. These are the ports that we're exporting to the host machine. Mapping the host port to the Docker port or container port, and also tying the volume, creating a volume on the host machine. Okay, so it's pretty straightforward in running this. And again, this is, I mean, you could argue that I could have just SSH'd into the machine and brought up the Docker container. Yeah, for sure. Right. From the reason for this, I'm trying to show you, you don't really want or need to SSH into anything. We're trying to move away from that practice. At the same time, showing you how you can tie Ansible into your Terraform workflow. Once again, this will become more apparent when we move into the fourth video and see how we can tie all of this together through a pipeline, which is Jenkins being the brains of the operation, how you can tie in Terraform and Ansible together automatically. All right, let's take a look at Jenkins Dockerfile, see what I'm doing here. So I'm pulling from the official Jenkins Docker image and just changing my user to root. Here I'm pulling the latest Vault binary, 1.6 at the time of this recording, and basically unzipping it and moving it to let's see, what am I doing here? Unzip Vault, and then moving Vault to my path, right? So it becomes available. Same thing doing with Terraform. Again, at the time of the recording, 0.13.5, pulling it down, unzipping it, and then moving it to my local path. Then removing the zip files to keep the image as small as possible. And then these two steps here is the way we have to install Ansible into this image as well. So now we have Jenkins by just calling on Jenkins here. We have Vault, Terraform, and Ansible all in this image. And then I drop down to the user Jenkins, back to this user. And from here, the image, you can create this image locally. I have it tied into Docker Hub. So Docker Hub automatically builds the image whenever I push or make a change to this Docker file and I push it to GitHub. So it's Docker Hub is tied to GitHub, and it automatically builds my image that way. Okay, let's go ahead and see how far we've gone. Oh, looks like we have an error here. We need to install pip3, right? So I updated our playbook just to add the way to using Ubuntu's apt to install pip3. This is how you do it. So let's go ahead and rerun this playbook and see how it works. And that's the thing with, Ansible or Terraform. It's really an iteration process. You continue to work through bugs and errors as you develop it. But once you have everything in place, then it becomes repeatable. That's the same with anything automation related. If you have to do a task more than once, then probably it's a good candidate to automate it. But again, the automation process takes a little bit of time to get right. And once you get it right, you appreciate and you're thankful for having it to rebuild, at any point in time, whether you're using this for tests in development and you want to spin up an environment quickly and bring down the environment quickly, or even in production, you can actually use it as a disaster recovery mechanism. Some folks use it that way as well. Now, for this particular thing that we saw here, we had two options, really. We could have gone back to our Packer file here. I could have added, you know, a line here saying, well, we should have apt-get install, what was it, Python 3-pip, right? So I'm actually going to leave it here, just to show you that this is more of an immutable infrastructure way of doing things. So let's say we found, just like what we did now, that this package is not installed. Well, the way to fix this in an immutable infrastructure method is to go ahead and recreate the Packer image with the force flag that I showed you earlier, and then rerun Terraform to rebuild the VM, and then you can apply the playbook with Ansible. Mutable way is the way we just shown right now with here, where you're building this, or you're adding the packages that you need to your playbook, your Ansible playbook. So just showing you the two ways of doing it. It really depends on a lot of factors. How often are you rebuilding this? Certain applications, it's just not practical enough to run infrastructure with immutability in mind. It's also a new concept for many folks. It might be a little difficult to digest in the beginning, but once you kind of get a hold of it, it's actually very powerful, because it really eliminates any sort of configuration drift, which you don't want to have. Okay, I think this is still running, so I guess it's installing the pip3 package, so it takes a little bit of time. So let me pause the video, and we'll get back to it when it's done. Okay, we're back, and it's complete. So it worked, and you can see here the logs. So basically, it installed pip3. The Docker module also for Python got installed. The Jenkins Docker image got pulled. Created the Jenkins container, and yeah, changed 4, OKs 5, everything's running. So finally, let's get to our Jenkins machine. So let's go ahead and grab the host name, fully qualified domain name. And if you recall, it was on port 8080. Let's go here. Well, looks promising. There we go. We've got our new shiny Jenkins instance running. Of course, I'll do this later after the video. I'll unlock it, go in, and configure what we need to configure. But basically, this shows how we're able to get all of this working. Okay, so let's recap on what we've done. So what we've done so far is we're able to see how we can bring everything together now in terms of building a Packer image, or an Azure image using Packer, I should say, getting credentials from Vault, putting those credentials into Terraform, getting Terraform to build that VM based on the Packer image, and then finally Ansible to go out and configure that VM, get Docker running, and so on. Now you might be asking me, well, Sam, why all this hassle to get this Jenkins machine running? Why couldn't you just run it in Kubernetes, or just run it just inside Docker somewhere, host it somewhere, or something like that? The reason why I'm doing this whole thing, like if I go back here and let's expand this, the reason why I'm doing it this way is because in many environments, for many customers that I speak with, they're still running either on-prem, or they're running perhaps Jenkins itself, or running in VMs. They haven't really moved to Kubernetes. They haven't adopted containers fully. So how can we still use CI/CD pipelines, best practices for automation and infrastructure as code in such environments where we still need to maintain VMs, for example, in a cloud or on-prem in VMware or something like that. So how can we still run in such environments? I did go through the weblog series and I showed how all of this could be deployed in Kubernetes. Really, with a platform like Kubernetes or Nomad, HashiCorp's Nomad, or even using the cloud native tools, everything becomes a lot simpler. So for example, the secure introduction of the Vault token is much easier in Kubernetes or Nomad or even Azure itself, because the platform itself has an identity that can be authenticated against. Whereas right now, because everything is loosely coupled, it's not really, there's no real sense of identity here because there's no platform that we're running on. That's where it becomes a little bit more challenging, and that's why we're piecing together these best-of-breed tools to get everything to work in perhaps environments such as this, like brownfield environments or legacy environments. So with that, I hope this has been useful. Thank you for watching, and look forward to seeing you in video number 3 of this series. Take care.